Hello everyone. This is the third session of the chapter amines, and in this session you can find the reactions of amines as nucleophiles, methylation, quaternary ammonium salt formation, and Hofmann elimination reaction with mechanism. Coming to the reactions of amines, amines give nucleophilic substitution reaction. Nucleophilic substitution, alkylation as well as acylation. In alkylation, when an alkyl halide is reacted with a primary amine, then hydrogen atom of the amino group will be replaced by the alkyl group and we get a secondary amine. In case the concentration of alkyl halide is more, then further the primary amine, the secondary amine reacts and form tertiary amine, and then finally quaternary ammonium salt will be formed. This is because nitrogen atom has a lone pair of electron which can be donated to the electron deficient alkyl group and it can form a quaternary ammonium salt. This will happen provided the concentration of alkyl halide is sufficient. So basically when we say where the alkyl halide will react with the primary amine and form a secondary amine along with the formation of HBr. The reaction is shown here in the form of an equation. CH3CH2Br ethyl bromide is combining with CH3NH2 methanamine to form CH3CH2NHCH3 secondary amine, methyl ethyl amine along with the formation of HBr. Similarly, in acylation, an acyl halide CH3CH2COCl will be combining with CH3CH2NH2 ethanamine to form a secondary amine CH3CH2CONHCH2CH3. Here, one is an alkyl group and the other one is an acyl group. Now, further, it will be forming a quaternary ammonium salt provided there is enough concentration of alkyl halide. So, primary amine on alkylation gives secondary amine, which on further reaction leads to the formation of secondary, tertiary, and finally quaternary ammonium salt. The formula of quaternary ammonium salt can be represented as R1, R2, R3, R4N plus X minus. There will be always a positive charge on nitrogen atom to show this nitrogen is electron deficient. It has donated its lone pair of electron to the electron deficient alkyl group. Now, coming to Hofmann's elimination reaction, Hofmann elimination is also known as exhaustive methylation. It is a process where a primary amine creates a tertiary amine and an alkene by treatment with excess methyl iodide followed by treatment with silver oxide, water and heat. So, in the previous reaction we had seen a primary amine when combining with excess alkyl halide will lead to the formation of quaternary ammonium salt. If the alkyl halide is alkyl iodide, for example, in this reaction, in this case we have taken a primary amine, then methyl iodide, CH3I, and we get the quaternary ammonium iodide. This quaternary ammonium iodide on combining with aqueous silver oxide, we get the corresponding quaternary ammonium hydroxide, which on heating we get an alkene, that is ethylene, and the tertiary amine. We'll see how the mechanism will be. It takes 3 steps in the entire mechanism. In the first step, that is step 1, the ammonium iodide salt is formed when amine react with excess methyl iodide as shown below. Here, primary amine, that is CH3CH2NH2 ethyl amine, is reacting with methyl iodide to form a quaternary ammonium iodide. In the second step, the substitution of the iodide ion with the hydroxide ion is achieved by the reaction between the iodide and silver oxide and the successive deprotonation of water by the silver oxide ion. This step can be illustrated in the form of the mechanism as shown below, where the I minus iodide ion of the quaternary ammonium iodide attracts the silver ion of silver oxide. At the same time, the O minus attracts the proton of water molecule, and the bonded electron will be shifted towards oxygen to form OH minus. The resultant hydroxyl ion takes place the position of I minus of quaternary ammonium iodide, and it will be forming quaternary ammonium hydroxide. This is happening in step 2. In step 3, the mixture is heated to facilitate an elimination reaction and form the required product. That is, the formed quaternary ammonium hydroxide, when heated, the beta hydrogen get eliminated and there will be the formation of alkene and tertiary amine, and the same can be understood in the step shown down in this slide. So here in this session we have seen the reaction of amine, that is nucleophilic alkylation as well as amination, and also Hofmann's elimination along with this mechanism.